Good day everyone. I am here to present my final project in linear algebra, which focuses on 3D graphic transformation using Python and matplotlib. In this part of my presentation, I will briefly explain the code that I created for my linear algebra final project, including how it runs and the mathematical concepts used behind it. The first four lines of the script import necessary libraries to enable advanced numerical computation, 3D plotting, and animation, specifically for visualizing and animating the movie strip. Imports the core NumPy library NP for numerical operations like generating coordinate arrays, and matplotlib library PLT for 2D 3D plotting. Access 3D tool to create a 3-dimensional plotting canvas, Func animation, class to handle the creation of animation, making the 3D plot move or rotate over time. Next, I will explain how the create movie strip function works, including the inputs, how the mesh is created, and the mathematical equations behind it. The function takes three inputs, U points, V points, and R. This controls the resolution and the size of the movie strip. First, the function creates two parameters vectors. The first one is U, which transform our movie strip in 3D space. It begins by converting the rotation angle from degrees to radians, which is required for trigonometric calculation. The rotations happens around the x-axis, so the x-coordinate remains unchanged. It's our axis of rotation like an angle. The y and z coordinates transform using matrix formulas derived from the linear algebra. The new y coordinate equals old y times cosine of the angle minus old z times sin. The new z equals old y times sin plus old z times cosine. These formulas preserve distance and shapes while rotating points in the x-y plane, creating smooth 3D animation. And this code sets up our visualization layout with 4 3D subplots arranged in a 2x2 grid. We use a for loop to create each subplot, the add subplot function with parameters 2, 2, plus 1 creates on a 2-row 2-column grid, placing each subplot at position 1 plus 1. The projection 3D parameters enable 3D rendering. For each subplot, we define viewing boundaries. X and Y axis range from -5 to +5 and Z axis from -3 to +3. We add access labels for clarity. Finally, each subplot is stored in the axis list, allowing us to display different transformations simultaneously in our animation. This code labels each subplot with descriptive titles to identify the 4 transformation types. Subplot 0 gets the title Translation with circular path, describing how the strip moves through space. Subplot 1 is titled Rotation, showing spinning motion. Subplot 2 displays scaling with pulsing to indicate size changes. Subplot 3 shows Reflection, described as flipping. Each title uses the font weight parameter set to bold, making them stand out visually. This labeling helps viewers immediately understand which transformation they're observing in each quadrant of our animation, creating a clear and organized presentation of the 4 fundamental 3D transformations. And now I'm gonna show you how the code transform and visually demonstrate how this principle manipulate our object, the movie strip, in a 3D matplotlib in Python. The translation matrix MT implements movement it's an identity matrix where the bottom row is used for the shift values. For instance, to move the strip 10 units along the y-axis in the code, we set t over y is equal to 10 in the fourth row. Second column, this is a clever way to code simple addition y is equal to y plus 10 into a matrix multiplication framework. Number 2, scaling. The multiplication resizing. The scaling matrix MS control size, it modifies the diagonal elements to demonstrate non-uniform scaling. I intentionally set the S factor to 0.5 while keeping SY and SJ at 1. The resulting matrix shrinks the strip horizontally, showing how we can precisely control dimensions along each axis. The rotation matrix MR is the most mathematically involved, using sines and cosines to rotate coordinates around the chosen axis. In the code, I defined a rotation of 60 degrees around the z-axis. This matrix redistributes the x and y coordinates based on the angles, which visually result in a strip spinning in the xy plane. And that's all. Thank you for watching my presentation on 3D graphic transformation.